We have learned previously about some methods to solve equations, quadratic equations. They were the square root and the zero product method. In this session, we are going to use another method to solve quadratic equations. This method, we use it when we are not able to use the previous methods by taking square roots or by using the zero product property. I mean, as you, if you remember, of zero product property, I have to rewrite the equation as two factors, the product of two factors equals to 0. If I can do this step, I mean I can't find constants that the product of them is the equals to c and the sum of these constant equals to b, then I can't use that method. In this session, we are going to learn a new method in order to solve such equations. As we know, the standard form of the quadratic equation is ax plus squared, of course, plus bx plus c equals to 0. So in this method, in completing square, I have to isolate the c and take it to the other side of the equation. If a is not equal to 1, then I have to divide both sides on a. Then there will be a term I have to add. Then we will add the term b over 2a to the both sides of equation in order to complete the square. When we complete the square, we will get a factor as the square of binomial. We will take the square root of both sides, then solve the linear expression left. So let's revise the methods, steps of solving quadratic equations using completing square before we start solving examples. First, I have to isolate c as we did here. Then, if a is not equal to 1, a is the leading coefficient, then we have to divide both sides of equations on a. I have to take out I have to add this and add it to both sides of equation in order to complete the square. b over 2 squared. When we complete the square, we will get the factor as a square of binomial, take square roots for both, and then solve the linear expression. Let's see some examples of this. Solve the following equation using the completing square method. The equation is 7x squared minus 8x plus 3 equals to 0. The first step is to isolate c, to take c to the other side of the equation. How? By take away 3 from both sides. Then you eliminate this side. 7x squared minus 8x will be equals to minus 3. Now a is not 1, so I have to divide both sides of equation on a. Then x squared minus 8 over 7 x equals to minus 3 over 7. We isolate, we divide on a. Now we will find the term b over 2a squared. Here, this is equal to b here is minus 8 over 7. Okay, here is 4, and we will get 4 squared, which is 16 over 7 squared, 49. This is the term, then I have to add it to both sides of equation. Now x squared minus 8 over 7x plus 16 over 49 equals to minus 3 over 7 plus 16 over 49. As we know, any operation we do to the left side of equation, we have to do it to the right side of equation in order to keep the equation balanced. So we completed the square here. We can write it as a square binomial, which is x minus the root here is 4 over 7 squared. This term here equals to this one. This one equals to minus 3 over 7 plus 16 over 49. In order to add these two terms together, I have to multiply by a common factor, which is 7 by 7. Now I get x minus 4 over 7 squared equals to 7 multiplied to 3 is minus 21 plus 16 over 49. X minus 4 over 7 squared equals to minus 5 over 49. We need now to take the square roots for both sides, which is the the square sign with the square root. We have now x minus 4 over 7 equals to minus 5 over the square root of 49. We have unreal number here, which is minus. We know the square root doesn't have minus sign inside, so x equals to 4 over 7 plus or minus, here it is the square root of 5 multiplied with the square root of minus 1 over square root of 49 is 7. Then x will be equal to 4 over 7 plus or minus the square root of minus 1 is a term in mathematics called I. So this is the solution of this quadratic equation. I represent the square root of minus 1, which is unreal number. Let's take another example. X squared minus 10x plus 12 equals to 0. If I try to solve this by the zero product property, I can't find a two constant that when multiplied gives me 12 and when added to each other gives me 10. 12 multiplied by 1 gives me 11 if different signs. 6 and 2 and 4 and 3, all of them are not valid. So I can't use the zero product property. In this case, I have to use complete square. So first step is to isolate C. So x squared minus 10x equals to minus 12. Here supposed to be 9. So this term supposed to be 9. So x squared minus 10x equals to minus 9. Then a equals to 1. No need to divide by anything. So the term b over 2a squares equals to b is minus 10 over 2 squared. This term is 10 over 2, 5 squared, 25. So x squared minus 10x plus 25 equals to minus 9 plus 25. We add this term to both sides of equation. We complete the square here. We can rewrite it as x minus 5, the root of x squared and the root of 25. X minus 5 squared equals to 16. Now, if we take the square root for both sides, then we will get x minus 5 equals to plus or minus 4. So I have two solutions. When x is plus 4, then x equals to 4 plus 5, x equals 9. When x is minus 4, then when this term is minus 4, then x will be minus 4 minus 4 plus 5, then x equals to 1. Both of them are solutions for the same equation. Let's move on to other example. Okay. Let's see another example. Let's see x squared minus 6x minus 3 equals to 0. In this case, we can't find two constants. When multiplied gives me minus 3, and when we added them to each other give me minus 6. So I need to complete the isolate C by adding plus 3 to both sides. No need to divide on anything because a equals 0, then x squared will be equal to x squared minus 6x equals to 3. I will add the term b over 2a squared, which is equals to minus 6 over 2 squared. This term is equals to 9. 3 squared 9. So I have to add 9 to both sides of this equation. So x squared minus 6x minus 9 equals will be 12. For both sides, we will get x minus 3 equal plus or minus, or this root here is the square root of 3 multiplied with the square root of 3. So x minus 2 plus or minus multiplied with the square root of 2. This case x equals 3 minus or plus 2 multiplied with the square root of 3. These are the solution of the quadratic